Welcome to DriverDTrains. Thanks for stopping by. I'm your host, DriverD. Our conductor and brakeman, Scratchy-C, went off to investigate a noise. In December 2024, DCC-EX announced the release of the EX-CSB1 Express, an all-in-one plug-and-play command station and booster. In my last video, we looked at how to configure the EX-CSB1 using the Arduino IDE. In this video, part 4 in the series, we'll look further at how to customize our DCC-EX command station's display. All of the examples we look at today will work with any DCC-EX command station, not just the EX-CSB1. Be sure to check this video's description for links to my other videos, as well as the various websites and products I mention here. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. We won't be going far today, but we'll cover a lot of ground, so hop on board and we'll roll on out. Customize DCC-EX command station display. Now that we've learned how to use the Arduino IDE to configure our DCC-EX command station, let's look at some additional ways that we can customize the DCC-EX EX command station software. The examples we look at today will focus on how we can add additional information to our DCC-EX command station's display. Here are all the mileposts along today's route. First, we'll look at the 8 lines of text that DCC-EX EX command station normally shows on the display. Then we'll look at how to add our railroad name and a custom startup message to the display. After that, we'll learn how to add our current locomotive's speed and DCC address to the display. Finally, we'll look at how to display some useful information about our Wi-Fi in a couple of special situations. There's lots to see, so stay sharp because we're about to leave the station. Customize DCC-EX command station display. 8 lines of text in EX-CommandStation. Before we do anything else, let's make a backup copy of our DCC-EX EX-CommandStation software. That way, if we make a typo or accidentally delete something, we can always go back to what we had before that we know works. I'll assume that you've already set up the Arduino IDE and downloaded the EX-CommandStation code like we discussed in the last video. We'll head to the Arduino folder in our Documents folder and copy or duplicate the CommandStation EX folder. For our own reference, we'll add the EX-CommandStation version number and date to the folder name. We are now ready to edit the CommandStation EX.ini sketch in the Arduino IDE, so we'll open that now by double-clicking on the file icon. One other thing to note is that we need to keep track of any changes that we make to the EX-CommandStation code, because when we update to a new version of DCC-EX, we will want to make those changes again. So we'll keep a log of the different sketches we work in and which line numbers we edit. I'll include a log with all the edits to the code for today's video in a post on my community page. You can find a link to the post in this video's description. Now let's get to work. By default, DCC-EX EX-CommandStation can show up to 8 lines of text on an LCD or OLED display. This is true even if our display hardware doesn't have 8 lines. DCC-EX will scroll the text on the screen if our display doesn't support all 8 lines of text. When a DCC-EX command station boots after we first plug it in, it will show on its display the DCC-EX EX-CommandStation version number, along with the open source GNU General Public License under which it is made available. Once the command station is done booting, it will show up to 6 lines of additional information about its status, including its power status, free memory, and Wi-Fi information. Let's locate where DCC-EX displays each of these 8 lines in the EX-CommandStation code and see what the code for each of these 8 lines looks like. We'll start in the CommandStation-EX.INO sketch itself. If we scroll down to about line 72, we'll see a line that says void setup parentheses. The exact line number where this appears could vary depending on the version of EX-CommandStation we are using, but there will always be one line that says void setup parentheses. This is what starts running the EX-CommandStation software. Now, if we scroll down a little further to line 97 or so, we'll see a line that says display_start, followed by an open parenthesis. This is the part of the code where EX-CommandStation first starts sending information to the display. Just below this, on lines 99 and 100, we'll see 2 lines that start with LCD. LCD is the DCC-EX function to display a line of text on the screen. Even though the function is called LCD, it works with both LCD and OLED displays. Note that LCD is all in capital letters and must always be in capital letters, even if I don't say that. Just after the letters LCD is an open parenthesis. The LCD function will display the information contained within the parentheses. I won't always say LCD open parenthesis when talking about the code, but remember the parenthesis is also required. After the LCD and open parenthesis, there is a number, 0 or 1 in this case. This is the line on the LCD or OLED display where we want the text to appear. As I mentioned, by default, EX-CommandStation provides us with up to 8 lines of text. The 8 lines are numbered from 0 to 7. So LCD 0 is the first line of text at the top of the display, and LCD 1 is the second line down on the display, and so on, with LCD 7 being the 8th and last line at the bottom of the display. Note that if we don't use all 8 lines on the display, EX-CommandStation will move the text up on the display to the topmost empty line. So here are the first 2 lines of information we saw before that EX-CommandStation displays on the screen. The DCC-EX version number on LCD 0, which is the first line at the top of the display, and the DCC-EX general public license information on LCD 1 just below that. The third line on the display, LCD 2, displays the CommandStation's power status. This message originates from line 310 in the CommandDistributor.cpp sketch. It will display either that the power is on, off, or SC. We're not going to edit this line at all, but I will explain what the messages mean because it has caused some confusion. On means that the power to both the main and programming tracks is on. Off means that they are both off, and SC means that the main and programming tracks are in different states, with the power to one on and the other off. Also, if both tracks are on and also joined with the join command, the command station will display power on join. This behavior is different from what I showed in some of my earlier videos, where the command station would display whether the main or programming track was on. DCC-EX changed the behavior in EX-CommandStation version 5 when they added the Track Manager functionality to the command station, which allows us to independently configure each track as either a main track, programming track, or DC track. As a result, when we have one track on and another off, the CommandDistributor.cpp sketch that handles the display doesn't know whether it is a main track, programming track, or a DC track that is on. If we look at the CommandDistributor.cpp sketch, we can actually see the old code that has been commented out. Unfortunately, this has caused some confusion for users, as evidenced by the questions on the DCC-EX Discord server. According to DCC-EX, the SC stands for status conflict, but in reality, there is no conflict. The message simply means that the CommandDistributor.cpp sketch that displays the message doesn't know whether the track that is on is a main track, programming track, or neither. So if you see the power on SC message, don't worry, it is normal. Okay, let's look at LCD 3, the fourth line on the display. We'll find this back in the CommandStation EX.INO sketch. If we scroll down a little further in the sketch to around line 140 near the end of the setup function, we'll see that DCC-EX displays the word Ready on LCD 3, which we need to remember is actually the fourth line on the display. However, if we look at our command station, we won't see that on the display. That is because if we scroll down to the end of the CommandStation EX.INO sketch, we will see on about line 207 that DCC-EX also displays the amount of free memory on LCD 3. Since this line of code runs after the line that displays Ready, it will overwrite the Ready message with the free memory amount. We have now looked at what DCC-EX normally displays on 4 of the 8 lines on our display. For most users, the remaining 4 lines, LCD 4 through LCD 7, will be used to display information about our Wi-Fi network. There are 2 different sketches that contain this Wi-Fi information, depending on whether we are using an Arduino-based command station or an ESP32-based command station, such as the EX-CSB1. If we have an Arduino-based command station, we can find the Wi-Fi information in the Wi-Fi interface.cpp sketch. This sketch displays either the Wi-Fi status or IP address on LCD 4 and the port number, if Wi-Fi is active, on LCD 5. We can see 2 of the status messages on line 163 and 173. Then the IP and port information on lines 370 and 374. We don't need to edit these for this video. If we have an ESP32-based command station, such as the EX-CSB1, the Wi-Fi information will be in the Wi-Fi ESP32.cpp sketch. The information displayed on ESP32-based command stations, like the EX-CSB1, varies on whether the Wi-Fi is in access point mode or station mode. You can learn more about access point and station mode in my video number 4D, Configuring DCC-EX Wi-Fi. In access point mode on an ESP32-based command station, such as the EX-CSB1, EX-CommandStation will display the Wi-Fi network name, password, and IP address on lines LCD 5 through LCD 7. Note that because nothing is displayed on LCD 4 in this situation, the command station will display those 3 lines immediately below LCD 3. We can see these LCD commands in the code on lines 267, 269, and 271. When the ESP32-based command station is connected to our home network in station mode, EX-CommandStation normally displays only the IP address on LCD 7. Again, the command station will display this line immediately below LCD 3. We can see this on line 219 in the code. In my last video, we looked at how to add some additional code to display the Wi-Fi port address as well for both access point and station mode. We'll come back to the Wi-Fi ESP32.cpp sketch again later in the video to edit which LCD lines DCC-EX displays this information on. These are the default EX-CommandStation display settings for all 8 lines of the display. There are a few other DCC-EX features that sometimes display information on the screen. For example, if an EX fast clock is connected, the fast clock time will be displayed on LCD 6. But for this video, we'll focus on the standard items that most DCC-EX users will encounter. Display our railroad name and startup message. Now let's look at some ways that we can customize the information shown on the command station's display. We'll start here in the CommandStation EX.INO sketch. We'll start by displaying the name of our railroad or another custom message on LCD 0 at the top of the display, and then add a message on LCD 3 to show when the command station boots. We'll do this in the display start routine that begins at line 97. Let's take a moment to take a closer look at the structure or syntax of the 2 lines of code on lines 99 and 100 that show messages on the LCD or OLED display. As we discussed earlier, each of these lines starts with LCD open parenthesis followed by the line number on the screen from 0 to 7 on which we want to display our message. After the number, there is a required comma and then a capital F. The F function text macro combines everything within the next set of parentheses to display on the LCD as one bit of text. Notice that some of the text is in quotes. That means we want to display that text exactly as shown. However, note that the word version is not in quotes. That is because in the EX-CommandStation sketch, version is a constant, which is like a variable that never changes, that represents the DCC-EX version number. We can hover our mouse over the constant, version in this case, to see what its value is, 5.4.5 in this example. By the way, if we are ever curious about where a variable or constant is defined, we can right-click or control-click on the item in question and select Go to Definition from the pop-up menu, and the Arduino IDE will jump to the sketch and highlight the text where the item is defined. It would probably not be a shock to learn that the version constant is defined in the version.h sketch. But let's get back to our LCD functions. Note that even though there is a space between the quote symbol and the word version, when this text is shown on the LCD, there will be no space between the V and the version number. That is because the space is not inside the quotes, so it won't be printed on the display. Finally, note that each line ends with a semicolon. This is a crucial element that often gets overlooked when we are in a hurry. The Arduino IDE won't compile the code and will display an error message if we forget to include the semicolon. Now that we have a basic understanding of how to display a line of text on the screen, let's add a command to show our railroad name or other message at the top of the display, and a message to indicate that the command station is booting. We can do that here as part of the display start routine. We'll go to line 99, click our mouse, and press return to insert a new line. Then we'll add a new LCD command to display the name of our railroad or some other message on LCD 0. We'll want to make sure that we copy the format of the other LCD command lines exactly. So we'll type LCD, open parenthesis, 0, comma, capital F, open parenthesis, double quote, and then the message that we want to display, followed by a double quote, close parenthesis, and a semicolon at the end of the line. Remember that we can only display up to 20 characters on each line. We can also copy, paste, and modify another line of code if we want, which might save us some time and help ensure that we don't make any syntax errors. Next, we'll want to adjust the LCD line numbers for the DCC-EX version number and license information. To do this, we'll simply change the LCD 0 to LCD 1 on line 100 for the version number, and the LCD 1 to LCD 2 on line 101 for the license info. The command station will display the license information on LCD 2 while booting, and then display the power status on that line when the command station is ready. If we really wanted the GPL information on the display at all times, we could append it to the line with the version number. Now, let's add a message on LCD 3 that the command station is booting. Sometimes when a DCC-EX command station boots, after it shows the EX-CommandStation version number and license information, it will pause for a while, and there will be a period of time when the display freezes and nothing seems to be happening. This can occur when the command station has trouble logging onto a Wi-Fi network, or when we update the EX-CommandStation code using either the EX installer or the Arduino IDE. To help us monitor the status of the command station, both when we power it on and when we perform updates, we can display a message whenever the command station is booting, and then another message when it is ready. We saw earlier the DCC-EX displays a ready message on LCD 3 at the end of the setup process. If we display our message that the command station is booting on the same line, then once the setup function completes, it will overwrite our booting message with the word ready. So we'll display that message on LCD 3. We'll scroll to line 101 and insert a new line after the LCD 2 line that shows the license info. Then we'll add the new LCD code to display our startup message. We'll need to make sure we copy all the same syntax as before. We'll type LCD, open parenthesis, then 3 this time, comma, capital F, open parenthesis, double quote, and the message we want to display while the command station is booting, followed by a double quote, close parenthesis, semicolon. Note that there isn't enough room on the display for our message to say command station booting, but we can say CMD station booting or base station booting, so we'll try one of those. Now, when our command station boots, we'll see our startup message. Unfortunately, as we discovered earlier, we won't see the ready message because EX-CommandStation will overwrite our message and the ready message with the amount of free memory. So let's move the free memory display from LCD3 to LCD7. This will allow us to see the ready message when the command station is done booting, and we can then use LCD3 to display locomotive information in the next section of this video. We'll scroll down to line 210 now and find the line with the LCD command for the free RAM and change the LCD3 to LCD7. Now, EX-CommandStation will show the free memory information on LCD7, the last line of the display. We're almost done. We just need to make some adjustments to how the command station displays our Wi-Fi information so that the free memory doesn't overwrite the command station's IP address on the display. We did this in the last video, but we'll repeat the process again here. Note that this only applies to ESP32-based command stations. We do not need to do this for Arduino-based command stations, as the Wi-Fi interface.cpp sketch that displays the Wi-Fi information for those command stations displays the IP address and port number on LCD4 and LCD5 and does not display any Wi-Fi information on LCD7. So we'll make the following edits in the Wi-Fi ESP32.cpp sketch for both station mode and access point mode. We'll start with station mode on line 219, where we'll find the LCD command that displays the command station's IP address. By default, this is on LCD7, but we'll change it to LCD6 if we didn't already do so in the last video. Note that if we added a line to display the port information on LCD7 in the last video, we can just leave it there. EX-CommandStation will overwrite it with the free memory amount when the command station finishes booting. Now we'll scroll down and find the LCD commands for access point mode. By default, there are 3 LCD commands we need to edit. On line 267 or 268, we'll change the LCD5 to LCD4. Then 2 lines further down, we'll change the LCD6 to LCD5. And then 2 lines below that, we'll change LCD7 to LCD6. Again, this is exactly what we did in the last video. And if we added a line to display the port information on LCD7, we can just leave it there as well. After we've made all these changes, we can instruct the Arduino IDE to verify the code to make sure there are no typos or missing semicolons, and then upload it to our command station using the round buttons at the top left corner of the IDE window. After the upload is complete, our command station will reboot, and now we'll see the name of our railroad or other message that we added at the top of the screen, along with a message to let us know that the command station is booting. Then, when the command station is done booting, we'll see a message that it is ready. And we'll still see the DCC-EX version number, track power status, command station status, all the relevant Wi-Fi information, and the free memory on the display. All aboard! Now let's see what else we can do. Display our current locomotive's speed and address. Let's customize our command station to display the current locomotive's DCC address and speed on the display. We can display this information on LCD3, the 4th line on the display, where we put our base station booting message, which says ready after the command station boots. This assumes that we moved the free memory display to LCD7, as we just discussed. To display this information, we'll edit the command-distributor.cpp sketch. This is the part of the EX-CommandStation code that receives inputs from our Wi-Fi throttles, such as Y-throttle and engine driver, and then forwards the commands to DCC-EX while sending messages back through its own Y-throttle server. If we scroll through the code, we'll see a number of different spots where the command distributor.cpp sketch broadcasts various types of information, including information about sensors, turnouts, turntables, and clock time. Eventually, at line 210, we will see the start of the bit of code where it broadcasts information about our locomotives. Line 212 has the details we need for the locomotive's address and speed. We are going to incorporate these into an LCD command on line 213, so we'll click our mouse in front of where it says #ifdef_sabretooth and press return. However, we are also going to need to do some math. Let's take a look. Here is what the basic command looks like. LCD3F loco $D speed $D, comma, SP loco SP speed code. The two $Ds inside the quotes tell the F text function macro to include the decimal values of the two variables listed after the quotes in the text string we send to the LCD. Those two variables, SP loco and SP speed code, are part of a larger speed table that also includes the status of the locomotive's throttle functions. So this command displays the text loco with the locomotive's DCC address, followed by the text SPD and then the locomotive's speed. There's only one problem. If we upload this sketch to the command station and try it out, we will see that although our locomotive's ID looks fine, the speed does not match what is on our throttle. For example, if our throttle is set to speed step 1, the command station will display 130, and if the speed is set to 126, the command station will display 255. However, if the throttle is set to -1, the command station will display 2, and with the throttle at -126, the display will show a speed of 127. Even more strange, if we set the throttle to idle while moving forward, the display will indicate speed 128. But if we set the throttle to idle while moving in reverse, the display will indicate 0. Finally, if we issue an emergency stop command, the command station will display speed step 129 if the locomotive was going forward, or speed step 1 if it was in reverse. Note that while I have shown these examples using the switching or shunting throttle, the results are the same when using a traditional throttle. The reason for this is that the locomotive throttle speed is represented by a number from 0 to 255, but not in one continuous line. Rather, the speeds are represented by two separate columns of 128 numbers each, one for forward and one for reverse, with the forward column of numbers stacked on top of the reverse column. Then, just to mix things up a little more, there are two separate speeds for idle, 0 and 128, and then immediately after those are two separate speeds, 1 and 129, for emergency stop. Are you confused yet? I know I am. So we need to do some math to make sense of the speeds in the internal speed table before we display them on the screen. And the exact math we do depends on whether the locomotive is moving forward or in reverse. Here's a short summary. If the speed table indicates that the locomotive speed is either 0, 1, 128, or 129, we want to show 0 on the display. If the speed is greater than 129, we want to subtract 129 from the speed. Otherwise, if the speed is less than 128, but not 0 or 1, we want to display the speed as a negative number by subtracting the speed in the speed table from 1. So we will create some if statements for those three scenarios, and then modify our LCD command accordingly. This is what the finished code looks like. Again, you can get a copy of the code from a community post on my channel that I will link to in this video's description. Now, when we upload our sketch and run our locomotive, we will see the speed displayed from -126 in reverse to +126 forward speed. The display will update anytime we change the locomotive speed or issue a function command. If we change to another locomotive, its speed will be shown on the display. In my next video, we'll look at how to add a second display to our DCC-EX command station to show the speeds for even more locomotives. Custom Wi-Fi messages for special situations. Before we wrap up for the day, let's take a quick look at two examples of special situations when we might want to show information about our Wi-Fi password on the display. I won't go into all the details here in the video, but you can find all the edits to the EX-CommandStation code in a community post on my channel if you think these situations might apply to you or if you're just interested. The first situation arises when the command station boots up in access point mode, even though we have configured it with our station mode password. As we discussed earlier, the Wi-Fi on a DCC-EX command station can run in one of two modes, access point and station mode. Normally, we choose which mode we want the command station to run in. However, as I described in my video number 4D, Configuring DCC-EX Wi-Fi, sometimes the command station will boot into access point mode even though we've configured it for station mode. This will occur when the command station is unable to sign on to our Wi-Fi network. This could happen because our home Wi-Fi router is not working, or because we've taken our DCC-EX command station to use at another location where it can't reach our network router. This could be in a basement, outdoors in the yard, or on a trip around the world. In any case, when this happens, the command station will boot in access point mode, but with our station mode home network password. So in order to use the command station in these situations, we will need to connect our phone or tablet's Wi-Fi to its access point network as shown on the display, but using our home Wi-Fi password, which of course is not shown on the display. This can cause some confusion as we may not remember that we need to do this. To alleviate this confusion, we can display a generic message to remind us to use our home network Wi-Fi password when the command station boots in access point mode while configured for station mode. The other unusual situation that might come up is when we want to configure our DCC-EX command station to use on a public Wi-Fi network and want to show the Wi-Fi name and password on the display. This could occur if we are configuring our command station to use on a club layout, for example, or with a dedicated Wi-Fi network router that we only use for our layout and DCC-EX. By default, EX-CommandStation will display the Wi-Fi network name and password in access point mode, at least on an ESP32-based command station, but not in station mode. However, we can have that information displayed in station mode as well. Again, I will include all the necessary code to do this in a post on my community page. But we've just passed the last milepost and our destination is in sight. So we'll call it a day and celebrate our accomplishments as we wait to see what tomorrow brings. What's next? Add a second display to our DCC-EX command station. In my next video, we'll look at how to add a second LCD or OLED display to our DCC-EX command station and use that display to show information about our locomotives. Be sure to subscribe to the channel so you don't miss any upcoming videos, and check this video's description for links to my other videos, including my video series on assembling a DCC-EX command station and my series on using JMRI's Decoder Pro app to control our trains. There's always more to see and do, but it's also important to consider what we've already accomplished. So we'll take a moment to reflect on what we've learned and come back ready for our next discovery. Until then, thanks for watching. Well, Scratchy, did you scare off the intruder? Well, that's a relief. What did you do? You chased it under the bed? All aboard!